okay, so we're talking about 11.3. And again, there's two different forms, difference of two squares, perfect square trinomials. Again, difference of two squares is when you have two perfect squares that are being subtracted, and so you can factor it like you see over here. Or perfect square trinomials when you have three terms, and the middle term is the square root of the products, or the product of the square roots, and then doubling it or multiplying by 2. If you were to expand a plus b squared, you would get what you have on the left side here. So we can kind of identify that for these examples here. For example, I could factor out 3, and then 9x squared is perfect square, 1's perfect square. Square of those are 3x and 1, work it out. Here, those are also perfect squares, but you have a middle term. The square of 4x squared is 2x, the square of 9 is 3. If you multiply and double it, you do get 12x in the middle. Square of this is 1, 4, square of that is x. So you have that. Zero product property. What this means is that you have to set the equation equal to 0 and factor and solve. And by factoring, what this enables you to do is to set each of these equal to 0. Because if that equals 0, then it doesn't matter what's going on with the rest of it, because you're just multiplying a bunch of stuff. And with one of the things you're multiplying at 0, then guess what? Everything else is 0. And we see the same thing here. So you have some opportunities to do that here. I'll probably do 1 and 4. 4 is a little bit, it's not that bad. But 1 is just asking to factor it. So you just pull out a 3, x squared minus 16, and then you can factor further. So that's why it's A. For 4, x plus y times x minus y. If you think about it, that becomes this. So you don't really need to solve for x, y separate. You could if you want. I mean, if you want to off to the side here, x plus y equals 10, x minus y equals 4. And if you see an opportunity where you can add the equations, you eliminate the y's. 2x equals 14, x is 7, and then you can solve for y, which is 3, and then plug it into here. But we also see an opportunity that x squared minus y squared is just that. And so we can just do 10 times 4, which gets us 40. So either way, you're fine. 5 will be a good opportunity for factoring, and that's kind of what I'm talking about, where they want you to solve for the zeros, and then, of course, once you solve for the zeros, take the difference. 2 is a little funky, but you can work backwards. 3 is kind of like 4, what I just did. 6 is kind of similar to 5. Then let's look at 11.4, solving product equations by completing the square. Sometimes that's kind of a good skill to know for the SAT. I'll kind of just do a problem because I think that makes the most sense. So what they first did was they put the 7 over to the other side. And it looks like they divide by 2 to kind of make this a pretty simple term, just x squared. Then the key part, this is kind of the key step, is you got to take half of -3 and square the result. So you're squaring -3 halves, which of course is 9/4. And then you add it to both sides, and then you can do some factoring. And then the nice thing is that after you factor, because this should be factorable, that's the whole point. The whole point to make it as x minus a number squared, x plus a number squared. Square root of 9/4 is 3 halves. So that was kind of the whole point again. And then, of course, add that result to both sides, you work it out, and you're golden. We got it. Here's example 2, kind of a funky one. So in this case, what is the value of r minus s? So we probably could do is you realize that, okay, if I were to FOIL this, I would definitely get 4x squared minus 4sx plus s squared. So now we know s is 3. And since we know s is 3, then the middle of the term becomes negative 12x. So r, of course, is going to be 12. S we know is 3. The difference is 9. So you're just kind of comparing left side and right side. You'd be going through the algebra course where you have to FOIL, so you have to be comfortable with that, especially with extra letters. And then you're just comparing the left side and the right side and kind of lining up terms. Obviously, if you FOIL it correctly, we see that S is 3, and if S is 3, then this becomes negative 12x, therefore R is 12. Let me do 4. 4 is kind of a crazy one, and I'll definitely do 1 here. 1 again is just very basic factoring. X minus 15 and x plus 5 equals 0, so x equals 15 or negative 5. But they want x plus 5, the value of that, which, well, oh, and x is less than 0. There we go. So obviously I'm going to go with this one here. And if I throw that in, negative 5 plus 5 is 0. So the answer is D as in dog. So that's number 1. Any questions about that one? Again, I just factored it, moved the 75 over, found 2 numbers that multiply negative 75 and add up to negative 10. Solved it, I got 15 and negative 5. But since x is less than 0, I go with negative 5, and then I answer the question they want. Then, hold on a sec here. Just gotta do a little quick update. Okay, for 4, that's a funky one. Here's how I would approach this one. This is probably, you see like as number 14 or 15 out of the, the non-calc, that's 15 multiple choice question. It'd be like the last or second to last multiple choice question. But what you could do is you can make up values. Like let's say R is 2. Let's say K is also 2. So you have x squared minus 2x equals 4 before. Or x squared minus 2x minus 1 equals 0. Now, that's not factorable. That's okay. But if I do quad form, so negative of negative 2 plus or minus b squared minus 4ac so you have 1 plus or minus root 2. So now I'm going to plug 2 in for R. So I like B or D because I do get 1 over here. And if I plug in 2 over here, I get root 8 over 2, which is 2 root 2 over 2, which of course is root 2. This one here would be 4 plus 8 times 4, which would be root 36 over 4, which is 9, which is 6/4, so that's not going to work for us. So what you're doing is you're using a strategy, right? You're deliberately making up numbers for some of these constants. So you work with something that's more tangible, solve it, of course, and use quad forms. So it's skills that you've done, but you just haven't kind of seen all pieced together in this way. But I'm showing you all the pieces, right, and how we're piecing it all together. So strategy again: plug in numbers for the constants, have hypothetical equations, solve like you would. They've done thousands of times already, and then commit to those constants for the choices, and gets an answer choice that lines up with what we solved for over here, which would have been D. So that's a little bit intense, but it's a good practice. 5 is 6 are kind of similar a little bit. So you'll do 2, 3, 5, 6 for 11, 4. And you'll do 2, 3, 5, 6 from 11, 3. So I would imagine this will take a little bit longer. I'll give you guys about 12 to 13 minutes, which is perfect because that will take us to 5 o'clock. Then we'll talk about the remaining 2 sections. And just so hold on. Just so I pace myself, 11.5's on, yeah, that's okay. Yeah, discriminant graphing, that's good stuff. Okay, so let me go ahead and stop sharing.